This question is from last year's exam. It's a DC motor question. It's a fairly basic one, just a couple of questions we need to answer. We've got our basic DC motor, we've got our battery over here, we've got a split ring commutator with a coil of 50 turns inside a permanent magnet with a field strength of 0.05 Tesla. The first question is just asking us which way that coil is going to oscillate. So if we look at our battery, we've got the positive on this side and the negative on this side, which means that our current is going to run this direction there and then back along there. Field lines run from north to south, so we have our field lines going this way all the way through our coil, and we have to figure out the direction of the force. This is where we're going to want to use our right hand rule. So your fingers, bear with me for a bad drawing, fingers are going to go in the direction of the magnetic field, then our thumb's going to go in the direction of the current. So if I work on the length JK, then my thumb is going to go upwards, and given that this is my right hand, the force is going to be going down. So the direction of our force is going to be heading downwards on the left hand side and upwards on the right hand side. So the black lines are my force. This is going to cause a rotation anti-clockwise, looking in this direction, which is in rotation in the side B. Last part we need to check is it going to oscillate back and forward? Is the force going to change direction at all? We have a split ring commutator, so that's going to reverse the direction of our current every 180 degrees and ensure that it keeps rotating in the direction B. So that gives us our answer B. The coil is going to rotate in the direction B as shown. Second part of the question, we have to find the magnitude of the force. We are given a current of 2 amps. We know the number of turns is 50, so we have N is 50. We're given the field strength as 0.05. And the last thing we need is the length. So the length is given as 6 centimeters. We need to be really careful and convert this into meters because we need everything in our standard units. So 0.06 meters. The formula we're going to be using is F equals BIL. Now, because we have more than one turn, that's going to be the force on one of those wires. We have 50 of them, so we're going to need to multiply that by the number of turns. Putting all our values in, we have 0.05 multiplied by 2 amps, multiplied by 0.06 meters, and lastly multiplied by 50. Putting that into our calculator, we get our final answer of 0.30 newtons. And we don't have to give a direction because it asks us for the magnitude, and we've already set the direction in the previous question anyway. So there's our answer. There's another couple of marks for us on an exam.